All right. Hello, everyone, and welcome to the technical community call for the month of April 2026. I'm Ed Marquez. I lead developer relations for Hedera at Hashgraph, and Hashgraph is that entity leading key initiatives when it comes to engineering, marketing, and other topics for the Hedera ecosystem. So today we have very exciting updates and an incredible topic for every smart contract developer. And so before we get into that, I do want to get into some housekeeping things and recaps that are worth sharing with you. The first one is we recently wrapped our Apex hackathon, Hello Future Apex hackathon. So that was the last chapter in a 3-chapter series of hackathons that um, gave the opportunity to thousands of developers to build, hack, and deploy on Hedera. And right now, that's being judged. The hackathon closed on the 23rd of March, and you're going to see the closing ceremonies and announcements towards, in the next few weeks. But the closing ceremonies should be around April 27th. So stay tuned for more details if you want to see who the winners are and what the projects that they built were. The other update that I want to cover, and this is one of my favorite ones, is HederaCon is coming to Miami in May. So on May 4th, if you're going to be in Miami Beach, whether it's for Consensus or for HederaCon, you're certainly expected to join us there in Miami Beach to hear about an amazing set of speakers, to hear great panels, great talks, and understand what's the latest in the industry, what's the latest in terms of broad interest topics. And you're going to hear from key thought leaders at HederaCon. So be sure to write that in your calendars and diaries. HederaCon on May 4th in Miami. And then in terms of other events, if you're going to be around in ETHCAN this week, there's going to be a hackathon or a hackathon track that Hedera is also sponsoring. So certainly plenty of opportunities to engage with the Hedera community and with the Hedera ecosystem. Now, the other thing that I do want to mention is an upcoming launchpad for projects. So this is, you can think of this as an incubator. And so those projects that come from the hackathons, maybe current builders, if you're interested in that incubator program, that's a fantastic opportunity to accelerate and take your project to the next stage of maturity and ensure that you're getting closer to those commercial and to those mainnet deployments. So that's enough of housekeeping. But do remember that this is being streamed to multiple channels. This is being recorded. So you can always go over it in your own time, and you can also share it with your network. Finally, I do want to thank the guys and girls behind the scenes helping make these calls possible, keeping our community informed. So Luis, Fermin, and the rest of the team, thank you for your contributions to making these type of calls happen. All right, so let's dive into smart contract development and specifically smart contract forking. So I do want to bring Kiran on the stage and to the screen. Hey, Kiran, if you could tell us a little bit about what you do, who you are, your background, that'll be fantastic.
Awesome. Thank you, Ed. I'm Kiran. I'm a developer advocate at Hashgraph. I work with Ed closely. But as far as my background goes, I've been a software engineer for the last decade, larger part of my decade. So I've been around, working with various companies. I got in the blockchain industry back in 2017. I've had the privilege to working on different parts of the industry when it comes to whether building that developer relations or even working as a technical lead. And I've also built various projects on other chains and on Hedera. So that's a little bit of my background. But as far as what I do specifically at Hedera on a daily basis, I usually work with partners, community members, and internally to basically support the engineering team and to provide that technical support as needed to kind of help them integrate various Hedera technologies. So my focus is primarily on the EVM smart contract side of things, but I'm all over the place. So
That's a great overview, and it's awesome, that you've been the work that you've been doing with our team here and as part of the ecosystem. I can certainly confirm that you are an EVM expert and a great asset in that area with the knowledge that you bring and what you're able to do in terms of tutorials and documentation. I think it's worth sharing that with the ecosystem that you're behind a few of our latest tutorials on everything related to EVM. All right, so before you dive into the topic and do your session and your demo, can you give us a quick download of what is smart contract forking, and why does it matter? Like, if you could give us a quick intro and then jump into your content, that'd be excellent.
Absolutely. So on most EVM chains, you get the ability. If you're an EVM developer, you are probably aware of it. But the idea is, there is a specific set of tools available out there. If you're an EVM developer, that lets you test various real live smart contracts that are live on the mainnet. And so what happens is, you have the testnet environment. Yeah, you can test everything, but it has a limit, right? Because you're not playing with the real data. That is where there's tons and tons of data, whether it's the liquidity pools or in the DeFi sector, all of these kind of things, it's not available in the testnet environment. So what forking allows you to do is to fork a specific state at a specific block, and then basically inherit all of the data that is on the blockchain, and then it lets you test against that data. So what that means, it has various use cases, and we're going to go into a lot of detail today. But one of the use cases is, you want to, as an example, you want to play around with real data. Let's say you want to lend some HBAR on Bonzo, and you want to borrow some USDC, like those kind of things. You don't want to just do it on the mainnet, right? So what you can do is with forking, you can actually fork a particular state and then interact with those Bonzo contracts or Sarsa swap contracts or whatever it is, and you get access to that real liquidity. Even if everything that you do is a test environment, everything's fake, it's all locally done, but that's the idea behind forking.
That's amazing. That's a fantastic overview. And I think it drives the point of why it matters, right? So being able to have a controlled test environment, but that is representative of the actual mainnet state when it comes to contracts, liquidity, and so on at a given block in time. Awesome. So I'll pass it over to you. It's your time to, shine and go deep in the topic. So go for it.
Awesome. Let me share my screen. I think it should be shared. There we go.
If you have questions for Kiran or myself or anyone else in the Hedera team, do drop those questions in the comments. We'll be capturing and aggregating those, and then we'll get into some Q&A towards the end and then towards the middle of the session. So don't be shy and give us your comments.
Awesome. All right. All right. Let me start here. So I talked a little bit about forking, and today specifically, I'm going to be talking about Hedera forking, how Hedera has it set up, how it is a little bit different compared to some other EVM chains like Ethereum that you may be used to if you played around with it before. And if you're completely new, that's also entirely fine. I'm going to take you guys over all the things, when it comes to forking, how it works under the hood. And then, with Hedera, we also offer native capabilities on our smart contract layer, right? Whether that is interacting with Hedera Token Service, which is a native token layer on Hedera, or whether it's some other native functionalities that is only available in Hedera, right? If you were to test it today with the existing tools like Anvil, when you're using Foundry or Hardhat, you're not going to get very far if your contracts have anything to do with these native functionalities, right? So that's where fork testing comes in. All right, so all right, let me go on to the next slide. So, quick concept for anyone new to fork testing is what happens is it takes a snapshot of a live blockchain at a specific block and then basically runs it on your machine. That's basically the gist of it. You're dealing with real contracts because you're inheriting all those from the mainnet or testnet. You can fork either one. And then you're dealing with real balances, right? And then these are real token holders. The only thing is, you don't have to worry about gas costs because, it's practically free because it is free. Everything is local. You don't need to spend any money to test those. And you can actually impersonate any account. So if you know of any HBAR whale out there, you can actually, fork it locally and then impersonate that account and then do all kinds of testing. So it's amazing, the kind of things that you can do. One of the unique challenges with Hedera is if you were to just use the existing tools, right, as it is, that Foundry Hardhat provide, you are likely, I mean, if you're just dealing with the regular EVM contracts, ERC20, ERC721, and basically everything that you find on other EVM chains, not Hedera specific, then it will just continue to work. You don't need this library, right? You only need this library when you're working with Hedera Token Service, and other native functionalities like schedule service. As far as I'm aware, that's not currently available, but if there's a demand for it, it's very easy to add it up to our Hedera forking library. So you should have access to that as well. All right, that's the core of it, right? So let's move on to some of the differences, right, with Hedera forking and without Hedera forking. You can see here without Hedera forking, what happens is, let's say if you call, if your test calls token.balance of, Anvil, that's what Foundry uses. It fetches that specific code using the smart contract bytecode using ETH get code, which in our case, it would be that specific address that is designated for Hedera Token Service, right? If you're familiar with the native token service, how you can interact with it from the smart contract layer, you are interacting with that contract address, 0x167. And then if you just run it, run the test locally, you're gonna get an error. You're gonna get an invalid FE opcode or something like that, and it's gonna crash. And you don't want that. You want the full set of testing availabilities, functionalities that you're familiar with. So then with Hedera forking, and I'm just talking about the Foundry here, but it works similarly on we're going to touch into the differences between how Foundry and Hardhat works in terms of forking later. But the idea is there's a setup with Foundry, at least. It deploys that contract, and it emulates everything, so nothing is in state. And then what happens is when your test calls token.balance of, Anvil fetches the code, and then because it's emulated, the bytecode, it is actually found, and then it returns it, and then you can do all sorts of testing. That's the general idea. We're gonna deep dive into like under the hood to see what that looks like. So this diagram here, it basically shows what happens when your test calls token balance of, the example that I talked about earlier, on an HTS token. Now this is very important. On a regular ERC20 721 token, like I said, Hedera forking, that's not where it most shines. It most shines when you're dealing with these native capabilities. So there's two paths, right? Both start the same way. Your test makes a standard token call, and then left path is the red. The call reaches that address, and then it finds, this is without forking, but it finds no code, and then crashes. I explained this, but just wanted to explain it in a diagram so you are aware how it actually works. And then with Hedera forking, okay, it's gonna see that emulation code, right? It receives the call, checks if it has the tokens data cached, and if it's not cached, then it fetches the data from the Hedera mirror node API, and that's basically how the Hedera forking library works. So the data actually gets stored locally. So all the future calls that you make in, with that specific block, with that specific contract, it's all cached locally. So it's instant. Instead of waiting like 1 to 2 seconds on the first try, you usually have to wait because it has to go out to the mirror node and fetch it. Sometimes it may take 1 to 2 seconds max, but otherwise, after it's cached, you target a specific block, it is instant. All right, so why is Hedera different, right? We talked a little bit about it, but on most standard EVM chains, every contract is a bytecode your tools can read, right? You fork any address, and then you get real code back. Hedera is different, right? There's 4 different types of native services, that probably more. Now I haven't even listed the schedule service here, but these are located on 4 different addresses. The HTS we mentioned, 167 address, and for all of these, there's a very designated specific address that you can call. That's the precompile that you call in order to interact with the native layer from the smart contract side, right? This is built. All of this is actually built in the Hedera's core software. So when we think about it, when you're interacting with the precompiles, what's happening is you're not there's no smart contract code behind all these services. These are native services, right? So these are not deployed as bytecode. So when your fork asks, hey, what code is there in that particular address? Well, there's nothing to return. And that's the root cause why the regular forking test usually doesn't work with Hedera, with these native services. So what's the fix? Well, the fix is we have the Hedera forking library. It places the Solidity contracts in those exact same addresses for HTS, exchange rate, random number generator, account service, all of these. And then they respond to the same function calls as if they're the real services. And then they're backed by real data. They're not the original, but it's more of a stand-in that just knows the right answers. That's one way I can explain it. Well, you might be wondering, well, why can't we just use something like local node or solo these days, right? And that's a fair question. What happens is when you run your node using Solo, something like Solo Network, which lets you run the entire Hedera network locally with the consensus node, the mirror node, the JSON RPC relay node, all of those locally. What happens is you start from blank state every time. There's no real data. There's no pinning to a historical block. And then it usually takes minutes to even spin up versus seconds for a particular fork. So these tools are solving for different problems, and Hedera forking is solving for a very specific set of problems. So that's how the library builds that body double, as I were to call it. All right, so this is a brief architecture of how it works. I talked about the Foundry. Here we have the library. It has two implementations. We have one for Foundry, one for Hardhat. It shows two parallel paths. They're solving the same problem, right? Your test code sits at the top, and it doesn't matter whether you're using Hardhat or Foundry when it comes to your test code. And the only difference is Foundry side is more proactive. So the setup that is being done on Foundry side, that basically places those emulation contracts at the system addresses, right? On the designated system addresses. So when your test needs some token data, the emulation address, basically it fetches it from the Hedera mirror node, and then it stores it locally. It's like a contract that's allowed to Google something mid-execution. That's a brief analogy there. And then Hardhat side, it's more reactive. What happens is there's a background process that is constantly running that intercepts all the requests that are coming in, and then it fetches the right answer from the mirror node, and then it returns it before Hardhat even notices. So it's like your test never knows it talked to a translator. There's a translator in between on the Hardhat side, but on the Foundry side, everything is just deployed as part of the setup. So again, these are just technical details, how they work. At the end of the day, both of the paths converge at the bottom, you see there, because they both rely on the mirror node API, which serves the exact same real data regardless of the framework that you're using. So in a way, both read from the same data source, and then both get you to the exact same result, no matter which path you're taking it. So here I talk a little bit about the test flow. I've been giving an example of this balance of, but let's just continue to use that. So your test calls balance of. The token address has a small redirector that forwards the call to the HTS address, which is at 0x167. And then that's where the emulation lives in terms of Foundry, right? The emulation checks, have I seen this token? Okay, if not, then if it's the first time, then it's going to take a while. It says 200 milliseconds. Sometimes it may take a second. It really depends even on your network connection. So it really depends on various factors. But then once fetched, it's stored locally. And then the good thing about this is, let's say you are testing against a specific block, right? You run it the first time and it's cached locally. And then all the subsequent tests, even if you are offline, you don't have access to the Hedera mirror node API, as long as you're targeting the same block and the same set of tests, then it will actually run the test for you. So that's the advantage of something like the way that it works. All right. these are just, guys, these are just different ways of just representing the exact same thing. This goes into more of the technical details. We talked about how it works there. Step 4, token data in storage. Okay, you read it. Step 5 to 6, read the balance from local storage, return it to the test. There's a lot of things that is actually happening here underneath, under the hood. Because you see here, we have a box here for vm.ffi. Like these are another way of saying it. It's basically an API call that Foundry library uses. It uses curl underneath to fetch whatever data that your test needs. Then it extracts the token data, and then it writes to the EVM storage, and then it reads the balance whenever you do the balance of call. So there's a lot happening with this library. And I keep coming back to the same example, balance up, but it works the same way on no matter what kind of function call that you're testing. Let's talk a little bit about what this setup even is. And I think this will make more sense when I actually go over the demo in a little bit, in a couple slides. And we're going to see it all in action. Just want to set the stage first. So, we have one function call, the HTS setup that's in Foundry. Today, I'm just going over, I even have the demo on the Foundry set of tests, but the repository, the GitHub repository that we have, that actually has examples for both Hardhat and Foundry, so you should be able to play around with that on your own time. All right, so step 5 to 6 we connect, and then steps 7. I'm going to talk a little bit about this, but basically step 7 is, it says vm.allow cheat codes. All of this is just still part of the setup process. So the cheat codes, allow cheat codes, this is a very Foundry thing. But just to give you an overview, all it does, it grants a contract the ability to call other Foundry cheat codes. So, I talked about how you can impersonate someone, how you can even give yourself tons of HBAR, whatever it is, out of thin air in terms of testing. And these are just cheat codes that Foundry has, right? So you're able to use this in your in your test suite. So that's why you need the explicit permission, and all of this is visible when we go to the demo. Again, more diagrams here. This just talks about, we have the steps 1 to 4. We place the emulation code at address, normal deployment. It cannot target a specific address, so the library uses Foundry testing tools to write the code there directly. And the goal of giving you guys all these diagrams, all these architecture, is to really understand how it is actually working under the hood, right? When you deploy, like when the setup is run, I talked about how the contract is deployed initially, right? So first thing is it gets the bytecode, and then it writes the HTS address, and then it executes the constructor, and then there's a whole lot of things happening under the hood. All right, so some of the differences between Hardhat and Foundry, if I had to summarize it, right, they take different roads, but they all lead to the same destination. And you might be wondering, well, which one should I use? Honestly, it's up to you. Whichever one you already know and use in your project, you are welcome to use it. Today's demo is obviously Foundry, but if you're a Hardhat shop, the concepts are pretty much identical, and the tutorials, like I mentioned, it's in the same GitHub repository. One thing to note on Hardhat is currently one limitation is it does not work. It is not compatible with Hardhat version 3, and even with Hardhat version 2, there's a specific version that is all part of the README. It will likely be supported in the future. If there's demand for it with Hardhat version 3, but the Hardhat plugin, it works pretty well, similar to Foundry, and so it's just like it's tied to a specific version, Hardhat version 2, rather than version 3. That's the only thing that you honestly need to be aware of. And like as I mentioned, the as far as the state fetch, how that happens, the setup. All of these happen in a different manner when it comes to Foundry and Hardhat, but they're all the same thing. All right, demo. What is the demo about? So we're gonna have 2 different demos. But before I go, I just want to talk a little bit about what the demo is, so we can understand. So we have first demo is the basic ERC20 fork testing. And then the second demo is the advanced HTS fork testing. So the basic demo is basically it's a regular ERC20 contract, nothing to do with Hedera native services like HTS or whatever. So there's no special things to be aware of. It just works out of the box, and Hedera forking does support that, obviously. And then there's the advanced HTS fork testing. That's where we are actually going to be deploying an HTS token using smart contract, and then deploying it to testnet. And then after we deploy it to testnet, we're gonna fork a specific block, and then we're gonna run a whole bunch of tests, granting ourselves all kinds of allowances, impersonating, giving ourselves lots of HBAR, so we can interact with our different scripts, and all of that is taken care of. So setup is basically, by the way, feel free to follow the tutorial repository. If you go to the repository here listed on the slide, you should see both. You should see two folders actually, Hardhat and Foundry. Go over to Foundry, and then if you want, you can follow along with me, or sit back and relax, and you can play it around on your own time afterwards as well. The advanced demo, it actually, I have some bonus test here. I have a regular HTS token that we create, that we mint, and then we have all kinds of testing. And then on top of that, I actually have a real life testing with the Sausage Swap version 2 swap contract, and then the Bonzo Finance lending capability. So we're going to be swapping some tokens, and then we're going to be lending our HBAR, and then borrowing some USDC. And then remember that these cost me $0 because even if I have access to the mainnet data, the liquidity pool and whatnot, I'm able to test this because Hedera forking supports that. So both are cross-contract calls where the DeFi protocol internally transfers HTS tokens through the emulation. And that's the kind of integration testing that people are interested about. And we're going to look at those in the terminal. All right, I'm going to stop here and maybe answer some questions we have, Ed, before I go to the demo.
Excellent, Kiran. Great overview and an in-depth view. I haven't seen anything come through the chat, so a reminder that if you're tuned in, feel free to ask some questions. We did receive some questions ahead of time prior to the session, and one of those is about the contract types and maybe requirements, because you mentioned you're going to do some testing with ERC tokens, and some testing with HTS token contracts. And so the question was, are there any type of contracts or patterns that still might need testing in like the live network? And so I guess another way to look at the question is there anything that you cannot do through fork testing that may still require live testing?
Yeah, that's a good question. So as it stands right now, Hedera Forking Library, it does give you the ability to test most of the common functionalities as it relates to HTS. There are some functions like the freeze, unfreeze, wipe, and those kind of very native Hedera related features. Those don't have a corresponding support on the Hedera forking, but it's a matter of adding those, right? If someone has needs any of those functionalities supported on Hedera forking, you are welcome to open up a GitHub issue asking for that support, and we will get right on it to support that. So it's a matter of whatever people need, and there may be some things that it's not 100% available, right? You still need to, again, I just want to, with that said, I do want to be clear on two things. Just because we have this Hedera forking support right on Hedera does not mean it replaces your actual mainnet testing, all the auditing, everything that you do with the mainnet data, because for one, gas estimation will probably look different on production data, and for another, there's a lot of different things, like different functionalities that are not even available on Hedera forking. But last of all, you want to use Hedera forking to test your logic. And then if you want to absolutely make sure have that end-to-end testing before you go live, you absolutely need to be testing with mainnet data using real world scenarios along with thousands of other users who are also using the network at the same time. So it doesn't replace one or the other. It's more complementary to catch those bugs early, or to have those robust set of testing, so you have that peace of mind when you go to production.
That's excellent. All right, let's move on to the demo portion.
Awesome. All right, so let me open up my sweet. So I have here, I already have, I've opened it, the basic tutorial, and I am going to open up the code to see what it looks like. So, all right, let's see how I want to do this. So we have this repository. We have the Foundry, as I mentioned, and then Hardhat, right? And under Hardhat and Foundry, we have basic tutorial and then the advanced tutorial. Today, I'm going to be going over the basic tutorial. And there's a lot of tests already available for you to test, for you to start forking the network locally, and then start doing your all kinds of testing. One of the only things that you need to be absolutely aware of is when you go over to this foundry.toml file, the configuration file, you want to make sure that FFI is turned on. It's set to true. It's because what this allows you to do is the emulation, without setting this to true, the HTS emulation, it cannot fetch data from the mirror node. So it's a way of letting Foundry reach out to that external service. With that said, you also want to be absolutely sure that now with Hedera forking, it only reaches out to the Hedera mirror node, right? And this is, as far as the security side of things goes, when you're dealing with this, when this is turned to true, you want to absolutely trust all the dependencies that are in your Foundry library. Here, we don't have to worry about it, right? Because I only have the Hedera forking dependency, but there may be other dependencies that you have on your Foundry project. So when you set this to true, those other Foundry project dependencies also have access now to reach out to those external services. So you want to be careful there. But other than that, if you're just strictly, if you know all their dependencies and everything like that, you should be fine. And for today's demo, everything should just work out of the box. I'm gonna go over to a README file. I'm gonna have it open, and then we're just gonna go over some of these things. Let me do. Whoops. All right. So we have. Let's go over on the contract. All right. So here's a very simple contract that we have. We have an ERC20 token. It inherits from ERC20 ownable. You can deploy the token. Currently, it's set to my token MTK. I'm going to give myself these many tokens initially. And then we have a mint function, and that's it. It's a very standard token, a ERC20 token, but you could really have any kind of complicated smart contract here if you wanted to. And then let's see. And then we have this script. So this script is a Foundry deploy script. What this does is it deploys the basic ERC20 contract using, where is it? It deploys the contract, and then it displays some things here, right here, deploy ERC20 contract. And then we're going to have, and then it also shows the block number where it was deployed. Remember, it's usually you're better off targeting a specific block. If you don't target a specific block, it'll just get the latest block. And then if you do that, as we know, it's not cached, right, the data. So then it will take a long time every time you run the test, if you run against the dynamic, that block number, whatever is the current block number. So, and we're going to see there are some flags that you can pass in to target a specific block number. All right, so that's the basic deploy contract. Doesn't really do anything here too much. And then we have, okay. And then, all right, let me just go over and then see this in action. So we have, let me open it, terminal again. All right, so, if you just follow along the README, it should be pretty standard, right? You just install the dependencies, Remember, we need OpenZeppelin contracts for the ERC20 deployment, and then we need our Hedera forking. I already installed it, but let me just do it again anyways. Oh, looks like I didn't on this laptop. All right, so well, it's doing that, so that's fine. And then you wanna update your .env file. I already have mine, so obviously I'm not gonna show it here, but you wanna, oh, my bad. I'm actually on the wrong directory. That's why. Basic. All right, let me do that again. All right, it's already here, so I don't need to do anything. All right, so we have our environment file. You want to put in the RPC URL. So we're going to use testnet for this. We're going to deploy everything to testnet and then fork that locally. Then we have the private key. This is your ECDSA private key that you enter in. All right, we're going to load the environment variable first with source env. And then we're going to build the project with Forge build. Ignore these warnings for now. These are just simple warnings. You can skip them for now, but obviously in your production environment, you want to fix those kind of warnings. As long as we don't have any errors, you're fine. And then I showed you guys the deploy script. All we're going to do is deploy this contract now to our testnet. All right, we're going to deploy it. Going to take a while. All right, there you go. Let me do this. You see here, okay, we're deploying with the contract. I have this much amount of HBAR, and then ERC20 token, it's going to be deployed to this. We have the block number. It's very important. And I have all this information, and it's basically asking me to update our deployed contract, and we're going to do that in a little bit in our test file, because we want to replace whatever the contract is with the contract that we just deployed on our test file. So let me go over to test. And then what is the address here? All right. And then here I'm going to change. And then that's all I need to do is, I think, yeah. Now, what we're going to do is we're going to run the fork test. So let me go over quickly on what the test looks like. So at the front, in the beginning, we have simple. We're declaring our deployed contract to be this address that we just deployed. We have the owner, and then we have Alice and Bob. We have 3 different addresses. We're storing the token here. So the setup, we don't need. Remember the HTS setup thing? We don't need to do that here because we're not dealing with HTS functionality. So this is the standard setup. We're basically binding to the deployed contract so we can interact with it. And then we're getting the actual token owner, right? And then we're creating some test accounts, and then we have here vm.deal, right? This is basically we're granting owner, Alice, and Bob 100 HBAR. Ether, it's just a standard terminology here, but we're basically assigning ourselves 100 HBAR. This is the kind of things which is really fun and easy to do on Foundry. And then we have some functions here for testing. Read name and symbol, read decimals, total supply, all of this good stuff. And then allowed user to mint, transfer from owner to Alice. You see here vm.prank, that's another one. So what this allows me to do is it allows me to impersonate the owner of the account, of the token. And then all the subsequent call basically happens from the owner. So this is really, really handy, like these kind of, and then here we have multiple transfers with minting. And then anyways, let me just go ahead and run the test. And then we're going to see it in action. All right, let me just copy. Whoop, there you go. All right, let me just copy paste this on my terminal so we can see this more in detail. Let me get here. What's the block number here? Let me do block number. I'll do 15. Oh, I did not do that here. Oh. Am I in the correct directory? Oh, I'm on the hard hat. My bad, guys. Basic. All right, let me run this on a specific block. All right, I'm targeting a block right after it got deployed. Oh, I forgot to. Let me just do it here. Everything, my environment is just set up here. So let me run this code. There you go. So this specific block, it basically looks like it's using this specific block. And again, don't take my word for it. Feel free to, we saw the test. It's it's able to transfer even if we were not the original owners here. So there's a lot of, again, this is a simple example. This is a standard forking, right, that you're already used to on other EVM chains. So just wanted to quickly go over that. And you can also do something like, let me just to be safe, let me do 19 here. And then do that. Fork block number. There you go. If you do, 14 when it was deployed, and it fails because that contract has not been deployed yet. So that's how it's working pretty nicely. All right. That's the basic demo. We're gonna move over to our advanced demo, and that's where really all of the cool things lies. So we're gonna see that in action. All right, let me open up advanced README. All right, so we have, where is it? So all right, let me go over the contract first, and then we're gonna come back to the test. So we have a contract here, HTS token manager. We are interacting with the HTS precompile, right? It's set to address 0x167. And then we're going to save the token address, a bunch of events. Only thing that you need to be aware of, we have this function to create fungible token. You see here, what this is going to do is when we deploy this and then call this specific contract call, then it's going to set the name, the symbol of the token, and then it's going to utilize the Hedera Token Service precompile. And then it's going to set it's going to inherit from the smart contract. So this smart contract itself will be the owner of the token. And then the same thing with admin. We're going to set the admin key to be the smart contract itself. A bunch of other things, expiry, right? A lot of things that you're familiar with, how HTS, you can deploy an HTS token using smart contracts. We also have mint token. Right, HTS minting works a little bit differently compared to the traditional minting on something like ERC20, ERC721. So, this one basically mints the token to the treasury, which in our case is the contract itself. So it mints the token, and that contract owns that particular minted token. And then we also have a transfer token, which basically is a way to transfer the token to someone else. And you can get some information from about the token. And that's about it. It's very standard token, HTS token. So let's go ahead and, where is it? Let me open up my preview again so we can see this in a more friendly manner. All right, so we have, let me show over the test as well. So actually the script. So the script is the same as earlier. So we just have, we're just retrieving the private key. And then we are going to deploy the contract, right? Calling our token contract. And then it's going to show the address that the contract will be deployed to, and then the address of the actual token. Remember, when you're dealing with HTS token, those two are different because you are using the contract to deploy the token, but then the token itself resides somewhere else. So it's a two-step process compared to something like if you're just dealing with ERC20, ERC721, the traditional EVM smart contract layer. That's not really, it's all managed by one contract. But because everything is native, right? And there are some specific steps, and the documentation should cover all the details, all the differences, if you want to look at that later. And then we're printing out the contract address that gets deployed, blah blah blah. All right, let's go over to our test now, and then let's see our main test. So our test, all it has is, I mentioned earlier. So we're going to change this after we deploy the token. So, just to be let me just do the same thing that we did it for the other one. Oh, terminal. All right, let's just install the dependencies. It's like there's nothing to do on my side, so it just installs it. And then I already have my environment file sourced, so I don't need to do that. But the process is the same, right? And then we build the project. All right, again, these are just warnings. I'm not saying to ignore them, but for the purposes of the demo, we can. But you want to make sure that you don't get any warnings when you deploy to production. All right, now we're going to deploy the token. So let's just copy over this file just to see this in action. I'm going to be deploying here so we can see this in big screen. All right, deploy address. We got this much HBAR, HTS token manager deployed to this, the block number. By the way, I didn't do this, but I can actually go ahead and check it out here. Oh, there it is. I think that's the contract. Yeah, this is the contract that we deployed just now. You see, we're going to pay special attention to these. So nothing has happened yet. We haven't interacted with this contract. So let's go ahead and interact. So we have our contract address to be this. I'm going to go over and let's see what the next step says. All right, I'm going to export this variable with our contract address. And then we're going to call this create fungible token. Remember from a while ago, create fungible token basically deploys the, creates the actual HTS token. I talked about there is a two-parter. We deploy the token first in terms of HTS, and then you call the function to deploy the actual token, the HTS token. So this is what we're doing here. This is just, Foundry makes it really, really easy to do this. You can just use something like hash command. So this basically sends the transaction directly to Hedera. So we're still, deploying it on the testnet. So let's go ahead and check out there you go. That's another call. So if we trace it, well, I need to verify it, but create fungible token, you see. So we have 3 calls so far. Pay attention to this. We're going to come back. And then you can do all kinds of cool things, like you can use Foundry to, get the contract address. So the token address, sorry. But, if I do that, oh, that's not it. My bad. Oh, that's the raw token address. We need to extract the 20 byte. So it's an actual EVM address format. So let me go ahead and do that. And then come over here. And then let's check out our token. Okay, this is the token that we just deployed, created via HTS token manager. All right, looks good. Holders, okay, no one, 0 balance. That's fine. We're going to come back to these contracts a little bit later. All right, now we already know the block number, but now it's time to update our test. So first thing that we want to do, let me just here. I'm going to change this right to the contract address, and then what is our token address? I forgot. So there you go. That's the token address. I'm going to change that to our new token address. All right, that's the only thing that you need to do. This is the main function I was talking about earlier, right? This is what initializes the HTS emulation layer. This is very important. This basically deploys the Solidity emulation contract at address 0x167. And then because of this is what allows our test cases to interact with the different HTS functionality. So same thing here, we're basically, see this deal, we're giving the contract 100 HBAR. Really cool things that you can do. And we have get fungible token info, feel free to read through these test cases, but it's very standard stuff. And then we also have a test for approve and transfer from, and then transfer to multiple recipients. And then, yeah, that's it. So let's go ahead and run the test. All right. So I'm going to run this test. So what this is doing now, it's actually forking the contract that we just deployed. Sorry, the block number, the latest block number, and it's gonna run a bunch of test cases. Let me put in the block number actually, just to be safe. What was our block number? I forgot. Block number. Oh, there it is. So we will do. Where is the test case? Oh, there it is. Get the block number. I'm just gonna do 10. There's probably some settings here. I have to just to be safe. You can always put the block number here, so you know exactly what you're testing against. All right, let's go ahead and test it. Oh, I see. Okay, it's running the other test cases. This is not what I wanted to run. That's why it didn't work. Let me do this. Actually, I think I have a package.json file here that lets me test. So what I'm going to do, just to be safe, I'm going to move these Bonzo test somewhere else first. Test, so I don't. Oh, I moved the entire test. All right, test, saucer sub. All right, that should be good. All right, we just have one test. Again, I could just use my test file to just run that specific test file, but oh, it's still running it. Let me. Technical difficulties here. Let me just. Oh, there's a lot of stuff here. I am going to just do this, guys. Sorry about that. I'm going to nuke this and then just get it again. All right. Let me just run it again. I gotta do the whole thing again. So I already have the contract deployed, so I'm just gonna use the contract that I already have as part of the testing capabilities. So let me just do this. Let me just install the dependencies first. All right, while that's going, now we are going to, where is it? All right. Now I'm going to do this. Remember the setup I told you guys about? It takes a while to set up everything. It looks like there is an issue here. Oh. Okay, let me do this, guys. Test. All right. We'll see if that works. If not, I'll just go over the code section and hopefully we can get that result. Oh, there it is. All right. Well, thankfully that worked. All right. So we have a whole bunch of forks. We forked the contract, right? We tested it use on the forked state. You see here block number. Again, I'm just using the same contract that I had deployed a while ago. So we see if we go over here, if we go to this one, yeah, if we go over here, I go over to this contract. See, there's still 3 calls. So all the calls that we made locally, it's not on the testnet because everything is just running locally. All right. I have 2 sets of demos now. Fingers crossed it will work for the saucer swap. Oh, it should, because I see what's going on. So the saucer swap demo and the Bonzo demo, it actually forks the mainnet and then test against that. But then our other test against the testnet. That's why I was trying to run everything. So when I changed it to only run for targeting a specific our HTS fork, it worked. All right, let me go ahead and run. I'm gonna. So what this is doing is instead of forking the testnet, we're forking the mainnet, right? And then we are running the saucer swap fork test. And I'm going to go over the saucer swap the test, what it looks like, so we can see this in action. So we have it lets us interact with the saucer swap version 2 on Hedera mainnet. Again, this is interacting with the live saucer swap contracts, right? And because of that, the test accounts don't need real HBAR or tokens on the mainnet. And then we're using all kinds of Foundry cheat codes, deal, frank, to deal whatever amount of HBAR to impersonate, so on and so forth. And then we're basically creating balances out of thin air, and then impersonating the accounts locally on the fork. So that way, we're not dealing with actual mainnet transactions ever. Right. So this is the real saucer swap router contract. This is the WHBAR contract. This is the USDC. Again, these are like, as we know, these are HTS token, right? And then here, all we're doing is, initializing HBAR USDC, and then we're giving ourselves some HBAR on the mainnet. And then there's a whole bunch of test cases here. So let me just go ahead and see this. All right. So we have the first test, right? Deal USDC to trader. We're basically giving ourselves some USDC. And this is just a simple test that's there. The most important thing I want to have your guys' attention is this one right here. So this is the actual swap, right? Let's go ahead and check the test, what it looks like. So we're here as part of this test, we're giving the trader 10 HBAR, WHBAR, right, with the deal command. And then we're approving the saucer swap router to spend the HBAR, right? Okay. And then we're basically doing the encoding, all of the things that we need to do, because this is what we're going to be passing in later. And then that is being encoded, right? Path, and then recipient is trader, and then deadline, 5-minute deadline, blah, blah, blah. And then we're basically, this is more for testing. We're checking the USDC before. And then now we're calling, we have the call data defined, and this is the function that we're calling on saucer swap. And then we're calling it, right? Saucer swap.call with the call data. And then if it fails, it fails. Otherwise, the trader, it receives some USDC, and then we're checking the USDC after. So in a way, if we check what happened here, before the swap, we have this much HBAR, and then we approve the router to spend some HBAR, and then we spent this amount of HBAR, right? And then what happens is we are trading this amount of HBAR to USDC. So, and then we're receiving this much USDC. And then after the swap, now our balance is 0 as expected. And then our balance USDC after is exactly that. So this is a very simple swap, right? And not too much going on, but that's the idea, right? These kind of testing, it lets you do with Hedera forking, because as we know, USDC, right, all these all these things, they are HTS token. And so this is the clear use case for using Hedera forking in your own CI/CD pipeline, whatever it is that you want to do. One last test, and then I'll jump over to the slides, and we'll finish up the presentation here. I also have a section for Bonzo Finance. Here, this is a very interesting use case. So I'm going to go over Bonzo. We're going to quickly look over. We have the lending pool. I'm going to sweep, gloss over all of these things. The lending pool contract is here. Again, WH bar, USDC. This is the interest-bearing token of Bonzo. You get this back when you deposit H bar. And then let's go ahead and run our Bonzo test. And then at the same time, we're going to see the main deposit and borrow USDC. Yeah, there you go. So here, this is what lets us deposit H bar into the Bonzo lending contract pool, and then it lets us borrow some USDC. So we're depositing, we're dealing ourselves some H bar first, and then we're approving. Okay, blah blah blah. We're calling the deposit of the lending pool, and then we're getting some WH bar. We're checking the account data. Okay, all of that. And then it also checks the total collateral, total debt. We're going to see this in the output. The health factor, what is health factor right now? And then last but not least, we're going to borrow some USDC. We're going to check the USDC amount before, and we're going to call borrow. And then we're going to check the value USDC after, how much USDC we received. And then because we're borrowing some from the protocol, right, the health factor should decrease. That's basically how the lending pool keeps track of everyone's health ratio. So if they go below a certain threshold, one, then they get liquidated, right? And then we verify USDC was received. All right, let's jump over to here. This is the main, again, like there are a bunch of other tests, feel free to go through, but this is the most important one, right? We have deposit, okay, we're depositing H bar as collateral. We got some interest-bearing tokens, and then we're checking the collateral before, right? Total debt is 0 because I don't have any debt right now. And then I can borrow up to, what is it, 31, 36 USDC, I think. And then the loan to value ratio is 62%. So that's how much you can borrow. And then the health factor is basically infinite because I haven't really borrowed anything yet. And then we're borrowing USDC. So I received USDC, this much amount of USDC. And then now I still have this much debt. And then the health factor immediately decreased. So we can see here the whole, depositing some H bar and then borrowing USDC on the Bonzo contract, it seems to work perfectly fine. And I didn't use any real money or anything. It's all done locally in our forking environment. And we were able to do that because of this library, right? Again, the process, the Hardhat tutorial, by the way, there are some limitations there. And if you run into any bugs, feel free to open up a GitHub issue. But we have the exact same examples with the Bonzo, the saucer swap, and the exact same thing that we did, but with using Hardhat. So, you should be able to find the exact same set of tutorials over there. All right, let me jump over to the presentation to finish it off, and then we'll get some questions. And we talked about this. All right, we went over, so you can fork a particular block number to that. If you do, then you'll have that caching available. So the subsequent calls will basically not reach out to the network to retrieve those values from the mirror node. And then yeah, this is basically what happens in the demo. We're using, so the HIP 719 HIP actually explains how the precompiled works. How the something like balance of or transfer from on an HTS token at the precompile layer. How does that work under the hood? So 719 is what explains all that. All right. So there are two use cases, I think, for using this Hedera forking library, and they're different, right? Because the first use case is, okay, you fork the testnet, you deploy a contract, you pin to that block, and then test locally forever and ever and ever. There's no gas per run, and then your suite can run 100 times, and only the initial deploy costs anything, right? Because you're deploying that contract on testnet, you fork it, and you can run the test forever and ever. So that's a really good use case. Now, there's another use case which you may want to fork mainnet, is to because as we know, testnet data is synthetic, right? Mainnet has real holders. It has real liquidity, and you can tap into that. And there are also edge cases that you may not really catch if you just experiment with testnet. So some bugs only show up against production data, right? That's one of the main use cases why you would want to work the forknet. Sorry, not forknet, the mainnet. So this is a full development cycle. Where does this fit in your actual workflow? There are 6 stages. We write the contract, deploy to testnet, and then Hedera forking. The steps, 3 and 4 here are where Hedera forking lives. You have that forge test command. It runs locally and in CI. You can pin your block number. You get identical results, all of that good stuff. And then stage 5, that's basically when you test on real Hedera. As I mentioned a while ago in the beginning of the call, just because you use Hedera forking library to test something locally, it does not replace the actual testing on Hedera. There are a lot of use cases, right? But you still want to be testing against real data on the production network before you go to production. All right, and then sometimes there are going to be cases when fork testing is not enough, right? And you need to know what the tool can do and cannot do. And some of the scenarios I can think of is there are some unsupported HTS operations like freeze, enable KYC, pause. All of these are not yet available, but that doesn't mean they won't be available. If you have a really good use case that depends on these different precompiles, then happy to get those requests in on GitHub so we can take a look at it and work on those. Another thing is the emulation's overhead in terms of gas estimation. It does not really reflect the real cost, so don't budget production gas cost from fork test numbers. And then, in consensus ordering, again, this doesn't really matter as much for Hedera, but basically in a fork, transactions run in the order that you write them. And it's just a specific set of tests, right? On real Hedera, there's hundreds of transactions that may be happening that are interacting with the same contract. So you're not going to get the exact same set of testing. You can set up those complicated, complex, test, whatever that you need to do, but it still doesn't replace it. And then there are some things like custom fees, royalty and fractional fee deduction during transfer. It may differ from the emulation. And one more I want to mention briefly: crypto transfer precompile that has the multi-party transfer capability is not supported currently. If you have a strong use case for that, absolutely. Again, that's another thing that we can put in. It's a growing library, right? If you have any set of new things that you would like to handle from the library, feel free to open up an issue and we'll take a look at it as usual. All right, so last but not least, very easy, right? You forge installed, we set the FFI to true Foundry, and then the setup sets up everything, and then we test, and that's about it. There's not much to do other than just follow these simple setup steps. In 5 set of 5 steps, everything is good. And then key takeaways, summaries. One thing to note is standard fork testing breaks on Hedera. It's because of those native functionalities, right? So you need that Hedera forking library if you want that emulation layer. And it's just one install either on Foundry or Hardhat. And it basically fixes all of those issues that you may have encountered so far. And Hedera is EVM compatible, as we know, but it does have additional native precompiles, and these precompiles are amazing. And then the goal of Hedera forking is to basically bridge that gap by letting users test again against these native services. If you'd rather explore the repo quietly, that's perfectly fine. The README has everything on the demo that I showed earlier, and feel free to test it, make sure everything works. But yeah, last but not least, we'll leave it up for Q&A. But that's the end of my presentation.
Kiran, that was an excellent session, man. So thank you so much for joining us. Thank you for that detailed overview, that great summary, and of course the demos. I think the troubleshooting that you did in the demo was stuff of champions. Things tend to go wrong in live demos, but in the end, you were able to work out all of the examples. And yeah, a lot of valuable information in that summary. For example, when to do it, and then how to map it in terms of life cycle of development. And you mentioned clearly that it doesn't replace the actual testing that you have to do with the production environments, but it's certainly a great tool for development and for testing. There is one comment that I do want to highlight, which summed it up pretty well, which is effectively it makes your testing more sane. So I think I saw somewhere in X that comment, and I think that's a fair value add that Hedera forking, the library, enables. All right, so we're short on time. I haven't seen any new questions pop up in the chat. So with that, I do want to mention something that came up earlier, actually, in the chat, which was around quantum. And so and it's not related to the primary topic of the talk, but what I'll do is we should show this to the audience if you check out this announcement in terms of what Hedera or what the roadmap looks like for post quantum. In terms of the adjustments that need to be made and what's already post quantum safe. So with that, coming back to the forking topic, Kiran, any last thoughts, comments, recommendations that you might want to share for the developers and the audience watching?
Not much, other than I think maybe the reason we didn't have a lot of questions is I answered those on the presentation. But other than that, as I said, the library, the forking library, is it's sort of in progress. It's in that in progress state. So happy to talk on Discord or wherever if you guys have any ideas on improving it. But other than that, I think it should let most users out there the ability to test a lot of the things that was not possible before. Because a lot of, even myself included, before this library existed, you had to, if you had to, run your own tests, you'd have to run with real money, and that's not what anyone wants to do. So as we get closer, on another side note, Hedera EVM compatibility, we're working absolutely exceptionally hard to make that as easy as possible, so existing developers, EVM developers on other chains have that same native experience as they do on other chains. We want them to have the exact same experience on Hedera. So yeah, welcome aboard. And if any questions, issues, feel free to talk it over on Discord, and we'll help answer those. Thanks.
Excellent. All right, let's bring this session to a close. And then I do want to thank you, Kiran, for the excellent presentation and the excellent session. We're going to have you back for some future EVM related topics and demos. So, stay tuned for more content from Kiran later on. All right. This concludes the call, and thank you everyone for tuning in. So have a great rest of the day.
Questions if you want to cover it.
I guess okay, I think I see it. Why can I view ERC balances on Hashcan?
I can answer that. So a little bit. So Hashcan currently only supports, like if you go over to your account, you can only see the HTS tokens. The ERC20 tokens are not listed there. That is one of the many things that people have asked in the past. So that is something that we're working towards. But if you know the address of the ERC20 contract and it's verified, there are a lot of tools available out there, including Hashcan. If it's verified, you can actually go to Hashcan, go to the contract, and you can view the balance directly there. Or there's a lot of other tools available. You can interact with the JSON RPC relay. I'm talking more from a developer standpoint. But as far as seeing your ERC20 balance directly on Hashcan, as of right now, it's not there. But that is something actually we're looking into.
Awesome. All right. Well, now let's wrap up the session and bring it to the end. And so thank you everyone again for tuning in, and thank you, Kiran, again. Have a great rest of the day.